Hi, everyone. Welcome to AWS webinar. Today, we'll be talking about how to set up serverless data streaming on AWS. My name is Osama Naseem. I'm a senior product manager for Amazon MSK, and I'm joined by my colleague, Sai. Sai, do you want to go and introduce yourself?
Hi, everyone. Thanks for your time today. My name is Sai Madali. I'm a principal product manager with the Amazon Kinesis Data Streams service at AWS.
Great. So let's take a look at what's on the agenda today. So today we'll be talking about data streaming in general. We'll start with an introduction to what data streaming is and how you can stream data on AWS. We'll talk a bit about why serverless data streaming and why it's important. We'll then talk about two key capabilities that we've recently launched at AWS that cover serverless data streaming, namely Amazon MSK Serverless and Amazon KDS On Demand. And then we'll take a deep dive into each of those capabilities, and then we'll end the session with a brief Q&A. So without further ado, let's dive in. The first thing that we want to capture today is, or talk about, is common data streaming use cases. So the increased adoption for streaming data is, comes from our motivation to respond to our customer needs as quickly as possible. In today's world, data is being produced at massive volumes from a variety of data sources, and for businesses to make best use of that data and use it as effectively as possible, responding to it in real time is extremely critical. Think about some of the customer experiences that you may have gone through, such as shopping on a website and you're looking at something and suddenly a recommendation for an item similar to that or a complementary to that pops up. That recommendation is made possible by somebody analyzing your clickstream data in real time and showing you that recommendation. Or for example, your credit card company sends you a notification asking you whether that purchase that you made was indeed you or somebody else. Now that notification is only valuable in real time. If it comes 5 hours after the fact, and if your credit card was indeed misused, then it is of no use. So the value of data streaming becomes important because, or the need for data streaming is because the value of analyzing data in real time is becoming more and more important today. And this exists across various domains. It could be, collecting data from mobile applications to provide real-time notifications, just like talked about, analyzing clickstream data, responding to, various sensors in the field. So IoT analytics, you could be complementing marketing campaigns or personalizing, customer experiences in real time. And because of this variety of data sources or variety of data that needs to be analyzed in real time, that is where data streaming becomes really important, and we'll talk a little bit about as we go through the rest of our session today how data streaming can help you in solving some of those use cases. Let's talk about how you can enable real-time analytics in your sort of in your systems today or in your organizations today. Real-time analytics require a combination of certain capabilities. You need to be able to ingest, process, and analyze high volumes of high velocity data and from a variety of sources. And you have to do all of that in real time. So, there's if you go from left to right on this slide, there is your data source. So these are devices or applications that are producing data in real time. So, we talked about a few of those, such as, mobile devices or IoT sensors. There are other examples like log files being produced by systems and applications, or clickstream data that customers are using, are generating by the use of a website. Now, once all this data is produced or is being produced, you also need to be able to ingest it. And ingestion is not a simple problem to solve because your data is coming from tens of thousands of data sources, which can be highly varied in nature. So you could have an image file coming from one website, you could have some text coming from some other place, you could have a log file coming from another place, and you need to be able to make sense of all of that data. So it's highly varied data, and it's coming from a variety of sources, which is then need to be collected and ingested in real time. Now, there are systems that are capable of ingesting data in large batches, and which are maybe not as real time. And then there are systems that are capable of maybe ingesting data in at very low latencies, but not quite at the high throughput that you need for data streams. So data streamings or data streams are that unique mix of being able to ingest high throughput volume of data at extremely low latencies and making them available for consumption. Uh, then you have the concept of stream storage. So, once you've ingested the data, you also need to be able to store it for some time. While most applications that need data in real time might consume it right away, but some applications might need to, keep that data for historical purposes, such as later analysis or auditing purposes, and therefore storing a data for a finite amount of time is also important. And that is where replayability becomes very important. This could be because a certain downstream application crashed and needs to read data from the start of the topic or from the start of the stream, and replayability becomes important there. Then you have stream processing. So, records are read in the order they are produced, enabling real-time analytics, or streaming ETL, which is, where you start, drawing certain insights from your data. And then alternatively, you could also, sync it to a destination such as a data lake or a data warehouse, where you can then analyze this data, use it to feed machine learning models, and so on and so forth. So AWS makes it easy for you to, collect, process, and analyze data streams in real time. We have a variety of services that that are already present and have been around for a while that help you do that. So we have Amazon Kinesis Data Streams, which is a homegrown native solution for collecting and storing data streams for analytics. It's capable of storing high volumes of data at low throughput. It's one of the lowest cost data streaming solutions out there. And on the other side, we also have Amazon Managed Streaming for Apache Kafka, which is the last one in this slide, which is basically another solution to collect and store data streams for analytics. It runs open source Apache Kafka and lets you run open source Apache Kafka workloads on a managed service. And then we have complementary solutions such as Amazon Kinesis Data Firehose, which allows you to load data streams into AWS data stores. So this could be a plain and simple S3 bucket, or you could be sending your data to an open search index, or you could be sending it to a third party solution such as Splunk, or you could so basically whenever you have to deliver data in a serverless fashion, Amazon Kinesis Data Streams is your go-to solution. And then we have Amazon Kinesis Data Analytics, which is a service purpose-built to help you analyze data streams in real time. And that is where you can run streaming ETL, you can run event processing jobs, and it allows you to sort of process data as it arrives on an event-by-event basis. And it provides two solutions. One is a SQL-based solution, and the other is an Apache Flink-based solution, which allows you to do stateful stream processing. We'll dive in today's session. We'll cover more, Amazon Kinesis Data Streams and Amazon Managed Streaming for Apache Kafka, but we also want to touch upon the other solutions that we have today. So let's talk a bit about, what is the current situation with data streaming, and why we're talking about serverless data streaming today, which was part of our agenda. So today, you may have a variety of workloads that are running on these or that are using these data streams, right? So you could have workloads that are highly stable, and they don't really fluctuate a lot. So if you see this blue line or the curve under the blue or the black curve, is this is the traffic pattern that you have. It sort of stays between 30 gigabytes per hour to 60 gigabytes per hour. It has low peak to average difference, and what that means is that it has higher utilization of resources, and then it's also easy to plan because customers can or users can say, okay, if my peak is not, or if my average is not moving by a whole lot, I'm okay having fixed provision resources because I know that I'm going to end up needing them at a fairly high utilization. So these are stable workloads, and you need to provision for the peak, which is denoted by the green line. And what this means is that you're not wasting a lot of resources. But on the flip side, you also have other types of workloads, which are quote unquote highly variable workloads. So these are workloads where, imagine you're operating a live video platform. Your overall demand can be very spiky. In this example, the lowest could be 8 gigabytes per hour, and the peak in the evening could be about 80 gigabytes per hour, which is 10 times your sort of your base traffic. So while you need to provision for the peak to ensure that you're serving that 80 gigabytes per second of traffic, but what that means is that your average utilization is about 20 gigabytes per hour. And the peak to average ratio is pretty high in this case. And hence, what you see is a low utilization scenario where your resources, for the most part, are underutilized or unutilized. And as a result, your overall utilization is extremely low. And which then means that you either have to provision for the peak and be okay paying for those idle resources at all times, or you then need to manually scale up and down every time your traffic patterns change. And manual scaling can be tricky, can be error prone. You may not be able to respond as quickly as your traffic increases, or you may have your scaling increments might not be as efficient. So therefore, it can be tricky. It can lead to bad customer experiences, and therefore it's something which takes a lot of engineering effort to implement. And then you have another sort of type of workloads which are unpredictable workloads. So if you look at this one, your actual usage is denoted by the blue line. We'll go back a slide here, which is the blue line, and your capacity that you had provisioned is this green line, which is at 80 gigabytes per hour, or 80 gigabytes per second, beg your pardon. Now, the risk for balancing resource availability and cost is even more difficult when you have such workloads. And in this example, as you said, right, as you see that every time you go above the green line, your customers will experience throttling, which will lead to bad customer experiences. So if you have such workloads where the traffic pattern is highly unpredictable, or you have certain surges, a classic example would be a deals website. The moment a deal goes live, you can't determine how popular a deal would be, and based on the type of deal, it could be very popular or not as popular, and as a result, your workload could spike above your capacity or the capacity that you have provisioned, and this could lead to bad customer experiences. And planning for such scenarios is pretty hard. So if we take a step back and look at what all these problems tell us, is that customers want an easy button for their streaming data applications. They may have dozens and hundreds of such workload patterns, and their workloads may also be evolving over time. What is a stable workload today may turn out to be a highly variable workload tomorrow. And as data streaming becomes mainstream, it tends to become the central nervous system that connects these various systems. And now customers do not want to manage that capacity because, as we've learned over the past 3 slides, that it is not easy to manage that capacity. One of our customers has told us that they don't want to spend time on capacity planning and would rather focus on building games. They're a large gaming provider. So what we've learned is that capacity planning with data streaming systems is challenging. Customers care more about getting to market faster and reducing their total cost of ownership than being in control of their infrastructure. And equally importantly, they want to reduce the operational overhead of managing that infrastructure. Their workforce, their engineering hours are much better spent on solving problems that their customers care about. In our example, it's a gaming provider, so customers care about gaming experiences or new games. So now they can use those engineering hours or deploy those engineering hours towards game development or improving the experience of their customers, as opposed to fine-tuning data streams to achieve the maximum out of it. And that is what got us thinking along these lines. And interestingly, both of these services sort of did this at the same time, which tells you something about the state of the market as well. That it's we went back to the drawing board and we're like, okay, how can we solve this problem for our customers in a way that it sort of it preserves the value proposition of data streaming, but then also takes out all the pain points or some of the pain points that we have heard from our customers. And our answer is simple, right? It's two capabilities that live side by side. So you had Amazon KDS before and you had Amazon MSK before. Now both of them have introduced a serverless or on-demand offering. So Amazon Kinesis Data Streams is, it provides an on-demand offering which allows you to collect and store data streams for analytics, but without capacity planning. And similarly, with Amazon MSK Serverless, you get rid of the notion of managing brokers or storage volumes, and you can similarly, analyze data streams without having to manage cluster capacity. Let's take a quick look into Amazon MSK Serverless first, and then Sai will transition into explaining a bit more about Amazon Kinesis Data Streams on demand. So before we go into Amazon MSK Serverless, I want to briefly take you on a sort of on a historical journey of where we came from. So we launched Amazon Managed Streaming for Apache Kafka about 3 years ago. It's a fully managed service for Apache Kafka, and recently for Kafka Connect as well. And we allow customers to operate Kafka workloads on AWS without having to manage their own infrastructure. Now, what MSK does for you, there are 4 key things that we believe MSK does for customers, among other things. But the 4 key ones are: it makes Apache Kafka more accessible to your organization. How so? Because managing Apache Kafka, we have learned, is not easy over in a distributed environment. Customers have to hire specialized talent or trained talent in-house, which is expensive. And as a result, it's not accessible for a lot of the organizations. And by providing Amazon MSK or using Amazon MSK, you can make Apache Kafka more accessible across your organization. We also help you drive best practices through our own design, defaults, and automation. So we've learned a ton over the past few years of running Apache Kafka, and we've constantly added to our suite of best practices and recommendations for our customers to be able to run this in the best possible manner. What all that means is that it allows developers to focus more on application development and less on infrastructure management. And then last but not the least, Amazon MSK is committed to improving open source Apache Kafka so that the Apache Kafka software or the open source project stays healthy and keeps thriving. Some of the key features of Amazon MSK are, we have deep AWS integrations. We have, high scalability. You can add brokers. You can change broker sizes. You can add more storage. We provide observability of logs and metrics. And then we also provide rolling version upgrades, so you can upgrade to newer Kafka versions without any downtime for your clusters. These are some of the key features. We obviously have, iterated at a fast clip and added a lot more features over the past 3 years. And you're welcome to go look at our documentation. But in typical AWS fashion, we are always asking our customers, what more can we do for them? And that leads me to sort of share what some of the key feedback or some of the key requests that we've received from our customers. Customers have asked us about auto scaling, so they want to be able to not have to manually add stuff or let Amazon MSK take care of scaling completely because they trust us more. They don't want to be managing partitions. So if you're familiar with Kafka, Kafka has a concept of partitions, which are basically bin logs that are placed on the brokers that you run in Apache Kafka. And whenever you scale out or add partitions, you need to make sure that partitions are evenly balanced across your cluster to make best use of your resources. And customers don't want to do that because it's complex. And then they want to do all this at lower cost, of course. So these were some of the key pieces of feedback or sort of requests that we had received. So we went back to the drawing board. We're like, okay, what can we do? And that's what prompted us to go develop Amazon MSK Serverless. Let's take a look at some of the key features of MSK Serverless. So MSK Serverless provides, on-demand streaming capacity. It's streaming capacity that works like a utility. You use as much or as little as you need without worrying about running out of it. What that means is that you have 200 Mbps of write capacity and 400 Mbps of read capacity concurrently at all times. So each MSK Serverless cluster gives you up to 200 Mbps of write capacity and 400 Mbps of read capacity concurrently. And additionally, we have some partition level allocation, which is 5 Mbps and 10 Mbps to ensure that each partition in your cluster has the ability to scale up when needed, and that a single partition is not drowning out other partitions. In addition to on-demand streaming capacity, you provide throughput-based pricing. So this is where your total cost of ownership of your streaming infrastructure closely mirrors the the application pattern of your applications. You only pay, or you pay when you write more. You pay more when you write more data, and you pay less when you write less data. And same on the consumption side. So from a cost perspective, it is throughput-based pricing. So if I tie it back to some of the workloads that we saw earlier, highly variable ones, where you're not utilizing the capacity at outside of peak hours, then with throughput-based pricing, you're not paying for capacity outside of those peak hours. So that way, it can be a low-cost solution as well for given the workload type. So you pay a small base cost per cluster, which is 75 cents per hour in US regions, but it varies by regions. But it stays around the same sort of order of magnitude. Everything else is determined by how you use the cluster, as I described, right? So such as the number of partitions you create, the amount of data you write or consume, and how long you retain that data. And what the pricing model allows is for you not to have to pay for peak, and instead scale your cost during periods of low activity. And as with MSK, data replication comes at no additional cost. So we replicate your data 3 ways. So the cost of each partition and cost of each GB of data written includes the cost of, includes the benefit of 3-way replication as well. And another key benefit that we provide, or with MSK Serverless we provide, is automatic partition placement. So if you recall, one of the key requests that we receive from customer is to have more automated partition management. So auto partition placement, what we do is that we reduce a big operational concern from the customers, and we make sure that partitions are balanced across your resources so that your applications can continue to perform optimally without having to worry about heat imbalances in your cluster. Other key features include full compatibility with Apache Kafka. So you can continue to use your Apache Kafka applications that you use today with MSK Serverless. There are no differences in the API that we implement. So you can use the standard Apache Kafka produce a consumer API, or Apache Kafka Connect from a client perspective, and continue operating your applications as you do today. We provide the same level of security as MSK. So, your clusters are placed behind, are network isolated, and they're also isolated on the authentication path. So we provide, authentication through IAM. And as a result, we provide the same security posture as MSK, as well as encryption. And then we also offer same high availability. So, we leverage the multi-AZ setup of AWS to make sure that the resources that you have are placed evenly across availability zones. Let's look at some of the key benefits that MSK Serverless will provide to you and your teams. It is simple to use. So creating a cluster is a matter of few clicks in the console or an API call with very few inputs. You can also use existing applications, so you don't need to refactor your clients to produce or consume, which means all you need to do is change the endpoint your applications communicate with to get started. It lowers the operational overhead on your team. So you do not need to build any automation to perform scaling operations, nor do you have to spend operator hours to scale your resources manually. And then you also spend fewer engineering hours on maintaining your overall infrastructure, since the concept of brokers and storage volumes are abstracted away from you. And it's highly cost effective especially for highly variable workloads, as we saw before, because you're only paying for the data that you're sending, and as a result, you're not paying for peak in off-peak hours. That brings me to the end of the MSK Serverless section. I'll now transition it over to Sai to talk more about Amazon Kinesis Data Streams on demand.
Thank you, Usama. So we talked about MSK Serverless. Now let's talk about Kinesis Data Streams on demand mode. So before we get started, I want to first start off with a quick introduction of what is Kinesis Data Streams, or KDS. KDS is a real-time streaming data service from AWS. Now, since its very inception, the fundamental reason why customers choose KDS is the low operational overhead that they get with the service. Now, typically, when you're building a streaming data platform on your own, you have to, look at what instance sizes you want to pick, what storage you want to pick, test it, benchmark it, and then kind of, provision that whole capacity on your own and manage that on your own. Now with KDS though, it's dramatically different. You basically create a resource called a data stream or a stream, and then you use AWS APIs to write data into KDS or read data from KDS. Obviously, you have to tell us how much capacity you need, right? And for that, you interact with a construct called a shard. A shard acts like it has multiple roles, but one of its role is to act as a unit of throughput. So each shard provides you a certain amount of write throughput and a certain amount of read throughput. 1 megabytes per second in and 2 megabytes per second egress. So if you need 2 megabytes per second, you would have two shards. And say you need more capacity, you would simply add more shards to your data stream. So specifying capacity and scaling capacity is dramatically easy with Kinesis Data Streams. Shards also play the role of as a unit of parallelism. Because at the end of the day, with streaming data, the core thing that you're trying to achieve is you're trying to stream large volumes of data and process that at really low latency to address a bunch of use cases that Usama talked about at the very start of the presentation. Now, shard enables you to do that. So with Kinesis Data Streams, you use a partition key to distribute this data into the small chunks of units of work, and you process each chunk in parallel so that you can get to the lowest latency possible. So shards also play the role of you as a unit of parallelism. So that's how Kinesis Data Stream works at its core. Obviously, customers love what they see with Kinesis Data Streams. However, as we talked about, you still have this need to tell us how many shards you need, scale up that capacity up and down. And if you look at some of the examples that we talked about early in the presentation, it's not always easy to do that. The burden is still there on the customer to provision and manage capacity depending on the different data traffic patterns that you see. And you're always playing this game on how do I optimize so that we provide the right customer experience. At the same time, you're not really spending too much resources essentially, or paying for too much of unused resources. That's really why we built Kinesis Data Streams on-demand capacity mode, to address that specific customer need. When we built KDS on-demand, there were 4 key principles that we kept in mind. The first principle is it has to provide hands-free capacity management. So you don't have to worry about, hey, what type of policy do I need? When do I scale? Should that be proactive? Should that be reactive? When do I really scale down? All of that heavy lifting should be done by AWS and not by you as a customer. That's the first key pillar, which we deliver with KDS On Demand. The second one is it has to be seamless. Now, there is a breadth of integrations that you also leverage with Kinesis Data Streams. Again, a stream doesn't live in a vacuum. You're producing data to a stream by sourcing data from different databases or different applications. And you don't want to go change all those applications just because you want to use hands-free capacity management. So it has to be seamless for you to interact with the on-demand capacity mode. The third thing is this is not something that is just built for your test-dev applications or for experimentation and what have you. This has to be there for you to run mission-critical workloads. And since it's launched three months back, we've got multiple customers running several mission-critical workloads on the on-demand capacity mode. So because it provides the same high performance, availability, and durability guarantees that is provided by, that is typically that you're there with Kinesis Data Streams. The last key principle was you really want to pay for what you use, right? So you don't want to pay for capacity and then worry about how do I optimize this capacity. You just want to pay for the amount of data that is coming in, the amount of data that you're consuming, the amount of data that you're storing, the number of streams that you are provisioning, versus thinking about how much capacity do I really need in each of these streams. So pay for what you use is another key pillar of the on-demand capacity model. So let's just see how through the experience, you see all of these 4 key pillars being reflected back. Now, getting started with Kinesis Data Streams on-demand mode is extremely easy. All you do is create a name of a stream, select the capacity mode, that's it, right? There is no other options that you have to select. You just have to create the stream, and then you use the same put record API or the put records API to write data into the KDS stream running in the on-demand mode. You can also use the same get records API and the subscribe to shard APIs to read data from an on-demand stream. And a shard, like always, provides you 1 megabytes per second and 1,000 records per second for writes and 2 megabytes per second for reads. So as you can see, the core principles of KDS do not change between the provision and the on-demand capacity mode. The other thing that also customers have told us that they love about on-demand is you can switch all your existing streams, one or more, into on-demand capacity mode, right? So say you built, you already use KDS, you have a bunch of workloads running on KDS, you like this capability, you don't want to manage capacity, but you want to transition, we enable you to do that with a single click of a button. Now, the other beautiful aspect of this is there's no disruption for your read and write applications when you're actually making this change, right? So neither there's disruption, neither there's a need to, do any complex code changes. It's you go to the console, select the stream, or use an API and move that to the on-demand capacity mode. The last thing is you can also switch between the on-demand and the provision mode. So say, as an example, you started your journey with on-demand capacity mode. Now you want to go back to the provision mode, either because you think that gives you more, predictable, predictable performance, or that is probably more cost effective for you. You can take an existing on-demand stream and move that to provision mode. Now, when you do that, the shard count remains the same. So if you have a provision stream with 100 shards, when you move that to on-demand mode, it starts with 100 shards, and then it actually scales depending on how your traffic patterns scales over a period of time. So that's the second key element, which is the seamless aspect of it. It's how you can switch not just your existing streams, but you can also move between the provision and the on-demand as your needs change. So let's talk a little bit about the scaling mechanism, right? Because that is a core aspect of why you want to trust essentially the on-demand capacity mode. So let's talk a little bit more about that. Now, each new stream that you create gives you 4 megabytes per second and 4,000 records per second for writes and 8 megabytes per second for reads. That's how you start when you create a new on-demand stream. However, as your traffic changes, as it evolves, it can scale up to 200 megabytes per second and 200,000 records per second for writes and 400 megabytes per second for reads. So it really, the journey is, depending on how your traffic changes, we scale capacity up to that the threshold that you see on the right-hand side. So let's talk more in terms of how that scaling happens. So the way the scaling actually happens is every time you hit a new peak, we scale capacity so that we provide you enough buffer for us to absorb these unplanned surges that you might see. So the policy at its core level is really to ensure that you always have 2x more than your last 30-day peak. So say, imagine you're running a video streaming site, you're using KDS to do some real-time analytics. You want to really plan for like a news-breaking event that might happen. You don't know how much capacity you need, right? So what you start with is let's say your last peak was 40, you can burst up to 80. Now, say you see even a higher increase in traffic. Your traffic now is no longer 40, it's 60, it's just growing. So what KDS does is it realizes that you've hit a new peak and it scales up to 120 megabytes per second within a 15-minute period so that you can continue to ingest data without really being throttled and ensuring that you provide a very flawless customer experience. Also, each on-demand stream provides you at least 2x the write read throughput as much as the write throughput that you have. So that enables you to use one consumer for each stream. Now, if you want to add more than one consuming application and really get predictable performance, you can use the enhanced fan-out feature. Now, just to kind of recollect, enhanced fan-out is the capability that is provided by KDS to be able to add more than one consuming application to a Kinesis data stream. Now, when you use this feature, each consuming application gets its own dedicated throughput. And more importantly, you can add these consumers on demand without the need to provision and manage capacity. Again, it goes to the fundamental principle of on demand, where you don't have to manage capacity either because you want to ingest more data or you want to add more consumers. So that's how, in essence, how scaling works with KDS on demand. All right, so the last thing, the core principle that we want to cover is the pay-per-use pricing of the on-demand capacity mode. The overall pricing has really I would say, four key dimensions. You pay for amount of data in, which is per gigabyte. That also includes, like in the provision mode, the first 24 hours of data retention. You also pay for data retrievals, 4 cents if you're using the Get Records API, and 5 cents if you're using the Subscribe to Shower Enhanced Fan-out feature. You also pay on demand for the amount of storage beyond 24 hours. Now, bear in mind that you can retain data in KDS up to a year. So depending on the duration and the amount of data, you pay 10 cents for the first 7 days. And then beyond 7 days, you pay 2.3 cents. So that kind of gives you the ability to archive data within KDS without really worrying so much about costs. There's also an additional cost for every stream that you create and per hour, and it's billed on a per minute basis. So it's 4 cents for every stream that you create in your account. All these rates are in US East 1, and for more details, please check out the KDS pricing page. The other key element that I want to talk about is we use a 1 kilobyte rounding factor for data ingested. So if you have a use case where you have very small records that you want to ingest, you don't have to worry about optimizing it just because there is a certain way we bill data that is coming into KDS. Also, I want to talk a little bit about when is on-demand cost-effective compared to provision. And what we've seen and what we've heard from customers that point is about typically 10%. So if you have a stream that is greater than 10% utilization, it might be better off, might be more cost effective for you to run in provision mode. But if it's less than 10% utilization, you'd obviously see savings when you use on-demand mode. Now, one key point that I want to say is that with respect to utilization is operating the service for 9 years, what we've seen is customers when they move from provision to on-demand, they generally see like 90% of customers see at least 10% savings, right? So because if you look at your streams today, you would see that a bunch of streams are either poorly utilized and there's one stream that is heavily utilized. But if you move all of them to on-demand, then you literally are paying for capacity. You're not paying for capacity, you're paying for ingestion and retrievals, and that really dramatically decreases not just the overhead, but also the amount of the operational expenses that you're spending, by the needing to scale capacity and manage capacity. So that's the pay-per-use pricing and how it works with KDS on-demand mode. I think we talked about serverless, we talked about KDS on-demand, we've talked about why those are important, we talked about the benefits of using that, but I want to also touch base and try to take this back to what does this mean when you're building end-to-end solutions, right? And off the bat, it should be, well, hopefully it's apparent that AWS provides the most broadest choices for you to build any type of streaming data application, right? Now, typically when you build a streaming data application, it doesn't exist in vacuum, right? So you're obviously ingesting data from one point, you're processing the data. So you need capabilities and features that make the end-to-end solution, building an end-to-end solution a lot more easier. Now let's explore that with a couple of examples. Right? Let's just say I am an e-commerce company, I built an application, it's storing all the data in a DynamoDB table, things are working great, it's highly scalable, available, reliable. But now I want to expand that use case. I want to be able to do real-time personalization that we talked about at the earlier the presentation. I want to be able to tell show things to my user that are more relevant to them, right? I want to list the top 10 trends or top 10 deals that are happening at the same time. So that way it makes the overall customer experience a lot more easier. Now doing that with AWS streaming services is much more easier. Now let's just take that example. Say my data and all my data in DynamoDB captured in DynamoDB. With a simple configuration, I can now stream all the data, all the changes to your data to a Kinesis Data Stream. And because it's going to run in on-demand mode, I don't have to worry about managing capacity. So now also, say I want to process this data, I just want to focus on writing code. I don't want to worry about the underlying infrastructure. Great, AWS Lambda provides you a great option for that. So I can write my code in AWS Lambda in any of the programming language choices that I have, process the data, build my use case, and I'm up and running very quickly. It's just not about getting started. It's also that you don't have the overhead of managing infrastructure where your developers are focused on writing code, you are focused on bringing new use cases to market, and let AWS manage the underlying infrastructure and capacity for you. it's not only that you're building one use case, it also you can extend this use case, right? So say I want to take the same data, I want to move that to S3 because now my business wants to, do more in-depth analysis, right? So I built a data lake on S3. I want to move this data. I don't want to wait for days and weeks to move this data. I want to move this data as quickly as it gets generated. So I take the same data that I'm capturing in Kinesis Data Streams, use Kinesis Data Firehouse, and now stream the data into S3. So now I can build my in-depth analytics on top of S3 very quickly and keep extending this flow without a lot of overhead. Again, as you can see, all the options that you see here have serverless options, and you're not worried about provisioning and managing capacity. Now the question is, okay, this is great if I have DynamoDB and that's how I'm storing data. But what if I have a self-managed database? Because of choices that I want to make, I want to choose a self-managed database. That's really where the choice that AWS offers comes to the fore, right? So, well, for that use case, it could be the same company, it could be the same team, but I do have that use case, right? In that case, I could use MSK Connect, the serverless option for MSK to connect different platforms and ingest data into MSK and retrieve data from MSK. So you could use something like MSK Connect to stream changes, say from an Oracle database or a PostgreSQL database that you're managing on your own. You can stream all those changes using a WZM connector over to MSK. So once you got all the data in MSK, you could use a more powerful processing technology like Kinesis Data Analytics, which provides a fully managed Apache Flink experience for customers to do even more sophisticated stream processing. Right, so as your needs grow, as your use cases grow, you certainly want to address more customer needs, and Kinesis Data Analytics provides you that rich, processing framework for you to build more sophisticated applications. But again, I also want to extend this, right? I want to move this data to S3 to do my in-depth analysis. I can still do that. I can use MSK Connect to now stream the same changes, move that over to S3. And then I can do the in-depth analysis that we talked about, with the prior example as well. As you can see across these two examples, regardless of the use case, regardless of what infrastructure you have or what architecture you have, AWS is providing serverless options, that enables you to get started very quickly and scale very quickly and offload the heavy lifting of managing infrastructure over to AWS. All right, so we've talked about on demand, we've talked about MSK Serverless, but we've also talked about the provisioning nature of how these services work is not going away, right? If you're using MSK Provision, where you provision brokers, you select the type of instance, that continues to exist, right? And on the same thing on KDS side, you still can go provision the number of shards you have, scale those capacity up and down manually using APIs. Those offerings continue to exist. So we obviously want to kind of provide you a framework on how to think about when do we choose the provisioned options and when do we choose the pay-as-you-go options. So say you have a new workload, right, that has totally unknown traffic. Say someone talked about this, right? We're broadcasting a game or launching a new game, and we don't know what the demand is going to be, right? And for that, you can start with pay-as-you-go because you don't have any heuristics. So having AWS manage that capacity for those use cases is highly beneficial. On the other hand, say if you have predictable traffic, you know that every day 12 p.m. it peaks, every day 4 p.m. it kind of ebbs, and with the night you don't have a lot of traffic, and you have a very predictable mechanism on how traffic grows and how traffic goes down. For those use cases, provision might be more cost effective. It also gives you more control on how you're managing capacity, what configurations you want to have. As an example, say with MSK, you have access to more configurations on how you want to configure your brokers, how do you want to manage performance. So you get more more knobs essentially, and when you need that, obviously provision is extremely effective. Also coming back a little bit to the workload patterns, say if you have unpredictable traffic, right? So then again, pay as you go makes it very easy because back to that example, you don't want to throttle your customers at the same time. You don't want to pay for unused capacity, and pay as you go options kind of provide you the best balance there. However, if your traffic is consistent and you know that you can have 60-70% utilization, then using provision makes it much more cost effective. Finally, this also boils down to preferences, right? So a lot of customers have told us that, hey, while we believe that, yeah, we can drive some additional efficiency by using provision in terms of infrastructure costs, but at the end of the day, I'm actually spending that on either like having to deal with this, having these vast capacity planning meetings, and we just don't want to worry about that, right? For those type of low cost of ownership that I'm trying to drive to, I prefer the ease of hands-free management. The pay-as-you-go option is extremely attractive. Again, if you want to have tight control of like shards and KDS or brokers in MSK, provision offering is extremely attractive. And finally, a predictable cost is again another key aspect of provision, right? So either we pay for shards, you pay for brokers, and typically you know what the bill is going to be. So some customers like the predictability of that option, and they typically choose provision over pay as you go. The key takeaway here is that now you have two options that you can choose as you either adopt KDS or MSK, and depending on your use case, your business needs, you can pick either of those. All right, so that kind of brings us to the end of this presentation. Just a quick recap. So we've launched now both these offerings, Kinesis Data Streams on demand and MSK Serverless, are available in general availability. So it means that you can get started today. And please visit the documentation pages for each of the service to know more about the feature. And with that, we are ready to take questions. Thank you.